Welcome back, everybody. We are looking at the top of page 102 in the workbook and example 2. And in this problem, they're giving us a big list of functions, little f, and asking for us to find antiderivatives for each one. Let's start by reminding ourselves why we might be interested in this problem. So antiderivatives, we noticed on the previous page, are the key to finding exact values of integrals. Okay, and so what we're going to do is to calculate these antiderivatives, maybe try to notice some patterns, and then in the next video we're going to look down at this table and see if we can come up with some general formulas for antiderivatives of common functions, which is going to help us to calculate definite integrals. Okay, so let's start with part A here. They give us a function little f of x equals 3x squared, and they want an antiderivative for that function. Okay, remember, antiderivative is just the reverse of a derivative, so capital F of x we'd like to be a function whose derivative gives us 3x squared. Can you think of a function that works? X cubed works, because if you use the power rule to take that derivative, you're going to get 3x squared, and we can check that down here by just taking the derivative of capital F. Okay, and we sure enough, we get the function little f that we started with. That confirms that f of x equals x cubed is a correct antiderivative. Okay, what about B? What if we wanted a function whose derivative is equal to 4x cubed? If you think about that, you might notice that x to the fourth works, because if you take the derivative of x to the fourth, by the power rule, you get 4x cubed, and that confirms that x to the fourth is indeed an antiderivative of 4x cubed. Okay, what about cosine of x? Okay, can we play that same game with cosine of x? So can you think of a function, capital F of x, whose derivative would give you cosine of x? How about sine of x? Okay, and again, we can check that by just taking the derivative of our guess. And is the derivative of sine of x cosine of x? It is. You can look back in your notes and check that. Okay, so capital F of x equals sine of x is an antiderivative for cosine of x. Okay. Now, in the next set of examples, it gets a little bit more interesting. D, for example. Okay, we want an antiderivative for the function x squared. Notice that that's similar to what we did up here in part A. Okay, there we wanted an antiderivative of 3x squared, so x squared is the same function, but it doesn't have the 3. So question is, how would we change our answer to part A so that we just get x squared and not 3x squared? If you think about that for a minute, you can make that happen by just putting a 1/3 in front of the x cubed. Why does that work? Well, let's check it and see. If you take the derivative of this capital F of x that we've chosen, you're going to get 1/3 times the derivative of x cubed, which is 3x squared, and notice that the 3's cancel, producing the x squared that we wanted up here. Okay, so this does indeed work, and one way to think about our motivation here is we put the 1/3 in front of the x cubed so that it would cancel when we took the derivative and just get us back to x squared here. All right, let's do one more together here. What about E? Could we play a similar game there to get an antiderivative for x cubed? Okay, well there, if we take x to the fourth and put a 1/4 in front of it, that 1/4 is going to do the same cancellation, have the same cancellation effect that the 1/3 had in the previous example. And so checking this, we take the derivative of capital F, we're going to get 1/4 times 4x cubed. Those 4's cancel, and x cubed is what we wanted to get. So we've just confirmed that 1/4 x to the fourth is an antiderivative of x cubed. Okay, now we've done a few problems together, so you might want to pause the video at this point and see if you can do parts F and G on your own here. Follow the patterns that we noticed previously. Just take a minute to try those. Okay, and then when you're ready, you can watch the rest of the video. Okay, welcome back. So hopefully you've given a try to parts f and g here. Okay, and what did you get for an antiderivative in f? I'm hoping that you got 1/5 x to the 5th, and notice that if you take the derivative of that, you get back to x to the 4th. Okay, and then what about g? That one was a little bit harder, okay, because our function is a little bit bigger. It's kind of in two pieces, 5x squared minus 2x cubed. The nice thing about antiderivatives is that they have a lot of the same properties that derivatives do. So if you have a function like this that's in two pieces, you can kind of break it into parts. Okay, so we could come up with an antiderivative here by kind of pulling that constant 5 aside and asking, what would an antiderivative of x squared be? Well, we can look above and see that we came up with an antiderivative of 1/3 x cubed there. Okay, and then if we move over to the negative 2x cubed, pull the negative 2 aside and ask yourself, what would an antiderivative for the x cubed be? Well, that was 1/4 x cubed. Or I'm sorry, 1/4 x to the 4th. And so if we put that together, we get a possible antiderivative of 5/3 x cubed minus, let's see, 2 times a 4th is 1/2 x to the 4th. Okay, does that work? Well, let's check it. So what do we get if we take the derivative of capital F? Well, we look at our function up here, we're going to get 5/3. Derivative of x cubed is 3x squared. Minus 1/2 times the derivative of x to the 4th is 4x cubed. And notice that if we do the cancellation here, we indeed get back to the original function. 5x squared minus 2x cubed, that's the function that we wanted to get. It agrees with what we started with, and so we've confirmed that our guess up here was correct. That is an antiderivative of the function 5x squared minus 2x cubed. Okay, so in the next video, we're going to try to take some of the stuff that we learned in example 2 and see if we can come up with a nice table of antiderivatives for common functions that are going to come up over and over again.